Hello, I'm Chloe and I'm a PhD student in Fiona Watt's lab. I've always been interested in how a tiny simple embryo can develop into so many different cells and tissues within the body. So after I left school, I wanted to study for a degree in developmental biology. After this, I came to King's for a master's, and as part of this master's, I was in the Stem Cell Centre. I found it a great environment to work here and I really enjoyed my time, so I decided to stay on for a PhD. For my PhD, I get to reapply that interest that I have in cell differentiation because I'm working with induced pluripotent stem cells. And pluripotent stem cells hold so much promise in the field of regenerative medicine for many different reasons, but the reason which I find them interesting is that scientists can use them as a tool to model diseases. So by thinking about what we know in the embryo, we can apply these concepts to pluripotent cells in a dish and differentiate them to our cell type of interest. We can do this with healthy and diseased cells and then compare them. So the disease which I'm working on is called Bardet-Biedl syndrome, and Bardet-Biedl syndrome is a genetic condition. It causes blindness, it causes kidney problems, and it causes obesity. So what we can do is take cells which are easily accessible from these patients, so for example skin cells, we can turn these into pluripotent cells and then differentiate them into a cell type which is affected in the disease, so for example the kidney cells. Kidney cells would otherwise be really difficult to get from these patients. So once we have our differentiated cells, we can ask questions like what's wrong with them, why they're misbehaving, and why they're causing kidney problems. And by answering these questions, we can not only better understand how Bardet-Biedl syndrome works, but we could potentially provide better therapies to patients.
Hi, I'm Giacomo Donati. I am from Italy. I am a postdoc in Fiona Watt Lab at the Center for Stem Cell and Regenerative Medicine. And after my PhD, I decided to move to UK because I want to improve my scientific background and I want to increase my network, my scientific network. But also I wanted to learn more about adult stem cell, in particular in skin. So during my postdoc, I became involved in several projects, and particularly I discovered new molecular and cellular mechanisms involved in cancer, in skin homeostasis, and in skin repair. And during that time, I realized that some of my results could have some clinical relevance. And that's what I want to go from now. And if you think acute and chronic wounds, it's actually a really relevant matter in medicine. And in particular, for example, if you think there are millions of people that are suffering from chronic wounds and due to obesity, diabetes, or vascular diseases. And this is happening actually in an aging population. So also, I find very interesting that acute and chronic, particularly chronic wound healing and cancer have have a cohort of mechanisms that are shared. And in some circumstances, precise one, you can see that chronic wound actually leads to cancer. So with this in mind, in my future laboratory, I would like to develop a new, a principle at least, for a new therapy. And I want to create a new cellular therapy and possibly personalized instead of a classical pharmaceutical approach.
Hi, I'm Stephanie, I'm from France. I did my undergrad in biomedical sciences at the University of Glasgow, which gave me a strong biochemistry background. As it was a 4-year program, I spent my third year at McGill University, where I could focus on cancer and immunology. After that, I had the opportunity to spend my summer at the Rockefeller University in the lab of Michel Nussweig, where I could participate in a project on the molecular immunology of malaria. I then went back to UK, graduated, and I did a master's degree in molecular biology at the University of Cambridge at the LMB in the lab of Michael Neuberger and Christina Rada, where my project was consisted of studying the interaction between two proteins and mapping it through different biophysical techniques. So at the moment, I'm a PhD student in the lab of Fiona Watt, and I went from studying how two proteins interact to how a protein or a set of proteins as part of a pathway are able to influence cellular behavior and dynamics during tissue formation and how this is able to change the architecture of the skin during the development. So in the future, what I would like to do is to combine the molecular aspects of protein-protein interaction with the regulations behind cellular behavior and understand how this is orchestrated at the epigenetic level during stem cell differentiation.
Hi, my name is Dr. Christina Philippius. I'm a postdoc in Fiona Watt's lab at the Centre for Stem Cells and Regenerative Medicine at King's College London. I come from quite a diverse background in biology. I did an BSc undergraduate and honours degree in biochemistry and chemistry, and a master's in HIV vaccine development at the University of Johannesburg. My PhD was here at King's in Professor Anne Ridley's laboratory in cell signalling and migration, where I looked at the effects of insulin on endothelial cells. Now, between my master's and my PhD, I was fortunate enough to have a clinical research role at King's College Hospital. I worked with the hepatocyte transplantation team, developing a non-immunogenic hepatocyte transplantation for pediatric patients with acute liver failure. And it was during my time there that I experienced the passion for cell biology, as well as I realized how cell therapies can really address the unmet needs of medicine today. So the cell therapy I'm currently developing is using different subpopulations of fibroblasts in the skin. We know from previous studies in this lab done in mice that different fibroblasts have different functions. So if you have a wound, the cells from the lower region of the skin migrate and produce collagen to repair this wound, whereas the cells in the upper region form hair follicles and prevent scarring. However, if the lower regions produce too much collagen, you then get scarring. So if we can administer cells from the upper layer, we can prevent scarring. And this has many clinical applications, such as in mastectomy surgery with breast cancer patients. We can hopefully administer the cells and prevent scarring.
I'm Helen, and I'm the Laboratory Manager for the Centre for Stem Cells and Regenerative Medicine here at KCL. We're based at Guy's Hospital, which is renowned internationally for its pioneering health research. I began here about 9 months ago after completing my PhD in molecular biology. Previous to my PhD, I actually worked in KCL within the division of genetics and molecular medicine. It was here that I found my research footing and was encouraged to pursue a career in scientific research. After approximately 2 years working on novel therapeutics for Huntington's disease, I began my MSc at Imperial College London. During this time, I reached out to the molecular medicine unit at UCL and designed my own 6-month project in developmental biology. This research focused on defining the features of early progenitor cells for the heart and also sparked my interest in stem cell biology. I also developed an interest in cell signalling and began my PhD at the Kennedy Institute of Rheumatology, which is where Fiona established her first laboratory. Towards the end of my PhD and beyond, I was helping to establish a brand new lab at the Queen Elizabeth Hospital in Birmingham. I quickly realised that my strengths were in teaching and project management, and my interests were in scientific research. So with this in mind, I seized the opportunity at the CSCRM to put my skill set and my interests to the test in a role that involves a number of different responsibilities, including health and safety, project management, budget management, teaching, and also liaising with a number of different industry representatives and collaborators. I think even within my first few days at the CSCRM, I was reminded of the divisional enthusiasm and also the camaraderie that was on show here. And I think this is the reason that the CSRM continues to produce high quality scientific research and also impressive publication record.